All right, how's it going? Are we ready for this? Let's do it. Let me see if you can see this color very well. Oh yeah, totally. Okay, it looks lighter. Well, maybe not to you guys. Okay, so 2.2, direct variation. When we have direct variation, we're talking about y being a multiple of x. Oh, I'm starting too soon. Pause me and copy this stuff down. Okay, and then here's that. And you guys are going to hate me for this one, but it's a word problem. Pause me. And then just in case you couldn't see number 4, pause me for a sec and write that down. Okay, back to this. All right, so y is a multiple of x when we're talking about direct variation. So what the heck is a multiple? So multiples of 2 are 2 being multiplied by a number. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, and so on. So all this is saying is if I take x and multiply it by a number, I get y. So what that looks like is this. If I take x and multiply it by a number, I get y. K is a constant. This just means k is a number. Okay, constant means number. So if you're ever trying to, a lot of times the math term goes back to the English definition. So if you think about constant versus variable in English, constant means stay the same, variable means changes, right? Well, in math, a number is always the same value. 2 is always 2. It always represents the same thing. Whereas a variable like x, the value can change, right? So sometimes it helps to think about the English definition. So k is a constant just means k is a number, okay? And then this equation you guys need to memorize in connection to direct variation. So as soon as you see direct variation or varies directly, you before this quiz or test, you need to think y equals k times x, so varies directly. Okay, so example 1a, I mean, we can clearly see that this resembles this exact format with k equal to 2, right? So we can jump straight to yes, but let me show you just in case. Let me show you what this looks like. So basically, I want to know, is y just x being multiplied by a number? So I want to think of some values. If I plug in like a 1 and a 2 and a 3 and so on, okay? If I plug in a 1, I get out a 2. If I plug in a 2, I get out a 4, and so on, right? Well, this is my exact example from up here. Y is just a multiple of x. So another way of looking at that is to show this times 2 times 2. Sorry, I don't know if you guys can read that. I'm just drawing a little arrow and writing a times 2 to show that that's the pattern that's happening. So that's another reason why it's yes, okay? You might feel like you already know the answer to this one, and I'm totally cool with that. That's totally fine. But just in case, I'm sure there's a lot of people that don't, so I want to make the t-chart, and we're gonna just pick some easy numbers to plug in. It doesn't have to be anything crazy. I don't know why I didn't pick 0, to be honest. I should have picked 0. Plugging in a 1, take a second. I get a -1. Plugging in a 2, so just in case anybody's not sure what we're doing here, we're just plugging in, and then PEMDAS tells me to do the multiplication before the subtraction, so I end up with 2, okay? And then plugging in a 3, so pause me for a second, plug in the 3, and you end up with 5, right? So I'm looking for a pattern of what happens, but from here to here, and here to here, and here to here, okay? Let's look at for the easiest one. If I'm looking specifically for a multiple right here, I'm looking for multiply. What do I multiply by to get from 2 to 2? Not a trick question. Well, I would multiply by 1, right? 2 times 1 is equal to 2. Is that the same thing for here? Is that multiplying by 1? Not even close. So that one's multiplying by 1. This is not. Do you hear that crow in the background? Oh my gosh. It's so annoying. So annoying. That's not multiplying by 1. So if the pattern's not the same for everything, then it's not, it does not vary directly. The answer is no. This had a pattern of times 2, times 2, times 2, times 2. Okay. And you guys might have seen already from the get-go that this part of the equation doesn't match up with this. It needs to match up exactly. Okay. All right, C. Let's look for a pattern. I'm going to use a finer tip so that maybe it's easier for you guys to see. Okay, so I'm specifically with direct variation, I'm looking for multiplying. I don't need to worry about anything else. So how do I go from 1 to 1 and then 2 to 4 and then 3 to 9 and so on using multiplying? Pause me for a second, figure that out. So from 1 to 1, I multiply by 1. From 2 to 4, I multiply by 2. And I already know, since these don't match, the answer is no. It has to be the same pattern of multiplying, times 2, times 2, times 2, times 2. Okay? All right, I want you guys to try D on your own and answer yes or no. Okay, so hopefully you got yes for this one. And it's because the multiplying pattern does match. To multiply, or to get from 1 to 5, I multiply by 5. To get from 2 to 10, I multiply by 5, and so on and so forth, right? Oh my God, that crow is going to drive me bonkers. Is that driving you guys as nuts as it's driving me? Okay. I hate crows. I'm just going to say it. This is exactly why I hate crows. Okay. So in all the rest of the problems, we're going to have a similar setup. They're going to give us enough information to find the value of k. So the first thing we're going to do is find the value of k, and then we're going to answer the question, okay? So as soon as I see the words varies directly or direct variation, why am I using that thin point? I don't need that thin point anymore. As soon as I see those words, I need to think about y equals k times x. So I'm going to use the first set of information. I'm going to plug the y in, and I'm going to plug the x in. Oops, sorry. And I'm going to solve for k. And hopefully you already know how I'm going to solve for k. Get rid of multiplication with division, right? So I end up with k equals 3. Now I can write the equation with the k included, right? And then I can answer the question. It says find x when y equals 12. So I'm going to plug 12 in for y, and I'm going to solve for x. So I'm going to get rid of the multiplication with division again, and I'm going to get x equals 4. So this is just a baby step to get us to the word problem that you guys saw, okay? So I want you to, for B, first I want you to find the value of k. Make sure you're not going all the way. I want you to just find the value of k. Okay, so let's do that part first. So again, we're going to use y equals kx. It's the same directions for both problems. I'm going to plug in the y. Make sure you're putting the y in the correct spot and the x in the correct spot. So I'm going to do that. I'm going to divide by -3 to get the k by itself. So hopefully you got the value of k. Now I want you to answer the question. Okay, so let's finish it. So we're going to write the equation with the value of k inside. And then just like before, it says find x when y equals -1. So this is -1. I need to solve for x. Now here's where you need to remember how to get the x by itself when there's a fraction in front. So hopefully you're thinking about multiplying by the reciprocal. So the way I get rid of a fraction is to multiply by the reciprocal, which is just flipping. So instead of -5/3, I have -3/5. That way the 3's cancel out and the 5's cancel out, and the negative times the negative makes positive. And then I end up with x equals a negative times a negative makes a positive, right? And then 3/5 times 1. Okay, now we're ready for the big bad word problem. It's not bad, actually. All right, let's do it. It's actually exactly the same as these two problems. Okay, a dripping faucet. Sorry, I forgot how to spell. A dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly. So there's our keywords. Varies directly tells me I'm going to use this equation with the amount of time the faucet drips. How long will it take for the faucet to waste 4.5 cups? So this first sentence is the same as the first part of our other problems. Step 1, can you see that? Yes. It's going to be finding the value of K. So they're giving us an X and a Y value. Now, what we need to figure out is which one is X and which one is Y. So let me grab a different color. Notice that we normally say Y varies directly with X, right? So the amount of water wasted, that comes before. So this is the Y value. Varies directly with, so whatever comes after the with is the X value. So this is the X value, okay? So right here when it says a dripping faucet wastes a cup of water, that's telling me that X equals 1. If it drips for 3 minutes, I mixed that up, didn't I? The amount of water wasted is the Y value. The amount of water wasted is the Y value. So a cup of water wasted. If it drips for 3 minutes, the amount of time is the X value, right? So I'm going to plug those in. I'm going to divide both sides by 3, and I'm going to get the K value. Then I'm going to write the equation with the K in it. And now it says, how long will it take? How long? That's indicating, okay, let me go back so I don't mess this up. It's been a long day. Time is X, right? So how long is going to be an X? Will it take for the faucet to waste 4.5 cups? That's a quantity of water, so that's the Y, right? So I'm going to plug 4.5, and I'm going to solve for X. And just like we did before, we're going to multiply by the reciprocal to get rid of the fraction. So 3/1. And I don't want to waste my ink. I'm running out of this purple color. So I'm not going to write the over 1 because it's not necessary. So I'm going to get rid of that. And then I'm going to go, okay, here's what I want you guys to do. I don't want you to get out a calculator, and I don't even want you to write it off to the side. What's 3 times 4? And then what's 3 times half? So 3 times 4 is 12. And 3 halves is 1.5. So this is 13.5. If you need to write it off to the side, you go 4.5 times 3. That's fine. Okay, and then what does X represent again? X represents the length of time, and the length of time has been given to us in minutes. So 13.5 minutes. Okay. And last one, write and graph a direct variation equation that passes through. So again, going back, hopefully this is getting stuck in your head because it's happened so many times. Direct variation is telling us we should use that equation. And then what the heck are they giving us here? Hopefully you answered an ordered pair. 1 second, I need to write this down. Okay. So they're giving me an X and a Y, an ordered pair. So I'm just going to do what I've been doing all along. I'm going to plug in the X and the Y. So 2 goes in for Y and 4 goes in for X. I'm going to divide both sides by 4. And then now I have my K value. and I can write the equation. So that's write a direct variation equation, and then now I need to also graph it. So for graphing, I need to think about, okay, what is this graph going to look like? Well, hopefully it's, you recognize this as an equation of a line. Y equals mx plus b, right? So the m is 1/2 and the b is 0. So when I'm graphing it, I'm going to start with a y-intercept of 0. And then this is rise over run. So rise 1 and run 2. So up and right, positive, positive. This is also the same as negative, negative, because a negative divided by a negative is equal to a positive. So down and left, and you can see that those dots make a line. So there's your y equals 1/2 x. All right, slightly over, I apologize. I still haven't gotten it quite down to 15 minutes, but we're pretty close.